Hey everyone, today we are going to solve the Daily LeetCode challenge of 4th March 2024 and the problem statement is bag of tokens. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array tokens that contains only positive integers and an integer power. Now, each element of this tokens array represents the value of a token. It means that the element present in the 0th index is a token with a value of 100. Similarly, this is a token with a value of 200. This one is the token with a value of 300 and this one is the token with a value of 400. Now, for each of the tokens of the tokens array, what we can do is we can perform two operations. First is face up or we can do face down. So, for each of the element, either we can do face up or we can do face down. Now, for performing these operations, that is for either performing face up or face down, we are having certain conditions. Now, what are the conditions? Condition for performing face up is that the value of the token should be either less than or equal to the power. Then only we can perform face up. And for face down, the condition is that the score should be at least 1. That is, it should be either greater than or equal to 1. Now, you must be wondering that what is this score? So, initially, we have a score of 0. And what we want to do is we want to return the maximum possible score. Now, how are we going to populate this score? So, whenever we are going to do a face up, what will happen is our score will get incremented by 1. That is, score will become score plus 1. And our power will get decremented by the value of the current token. That is, tokens of I. Similarly, when we'll perform a face down, what will happen is the score will get deducted by 1. That is, score will become score minus 1. And will gain a power of the current token. Correct? And by performing this two operation, that is, if we are present at the current index, right? Say, for example, if I'm present at this place at this element 100, then for this, either we can do a face up or we can do a face down. We can't do both of them at the same time, okay? Additionally, we need to keep in mind that we have to perform these two operations in such a way that we get a maximum score. Fine. Additionally, it has been mentioned that our game will stop when we don't have either enough tokens or power or score. So if we hit these conditions, then in that case, our game will get stopped. Now, what do I mean by we don't have enough tokens? It means that we have completely exhausted the array. Say, for example, I have processed this value, this value, this value, this value, and I have reached to this index. So it means that we don't have any more tokens left, right? So we can't perform either a face up or a face down, correct? So at that point, eventually, we have to stop the game, right? So by not enough tokens, we mean that we have completely exhausted the array. Now, what do I mean by not having enough power? Say, for example, we have been given an array of token as 500. Okay, say this is our tokens array. And the power which we are having initially is 10. And initially our score is 0. So in this case, can we perform a face up or a face down? So let's see. For face down, the condition is that we should have a score greater than equal to 1. But our score is 0. So we can't do a face down. Now let's see, can we do a face up? For face up, the tokens of I should be less than equal to the current power. So tokens of I is 500. So is 500 less than equal to 10? The answer is no. So we can't perform this phase up. So our game will be stopped and the answer would be 0. So this was an example of we don't have enough power, correct? Now coming to the third, we don't have enough score. So it was clearly visible in the same example that here we didn't have enough power to perform face up. And if we wanted to perform face down, we were not able to do the same. Why? Because the score was 0. If the score wasn't 0, and if it would have been 1 or 2, then we could have made a face down, right? But here, since the score is 0, we can't do a face down, correct? Now, from this example, it would have been very much clear that how important this power is for us. Because if we won't have enough power and enough score, then our game would be stopped, right? So let us take an example. Say, for example, our tokens array is 10, 20, 30. And we have a power of 10. Okay, this is tokens. So I have a power of 10 and initially our score would be what? It would be 0. So can I perform a face down? No, because score is not greater than equal to 1, right? So at this initial stage, we can only perform face up. So let's see, can we perform a face up? So we can see that here we are having a 10. So I can use this 10 to perform a face up, because for face up, what was the condition? The value of the token should be less than equal to power. So 10 is less than equal to power. So we can do a face up. So if we'll do a face up, what will happen? Our score will get incremented by 1. So it will become 1. And our power will get decremented by the value of token. So the value of token was 10. And so our power will get decremented by 10. And our resultant power would be 0. Fine. Now we will move to the another element. Say we are at 20. Now, since we have used 10, so let's remove 10 from our array. Let us assume that this 10 is not present over here because we have already used it. Okay, so now we are left with 20 and 30. Fine. Now let's see. Can I do a face up here using this 20? So the answer is no, I cannot do a face up. Why? Because for face up, what was the condition? The value of the token should be less than equal to power. What is the value of the token? It's 20. And it's 20. And what is the power? It's 0. So is 20 less than equal to 0? The answer is no. So we can't do a face up. But can we do a face down? So for face down, the condition was score should be greater than equal to 1. So score is greater than equal to 1. So we can do a face down over here. Okay, so if we will do a face down, what will happen? Our score will get decremented by 1 and we'll get a power of that particular value. So if at this point I'll do a face down, so what I'll get is I'll get a power of 20, correct? And our score will get decremented by 1. But let us see one thing, that irrespective of whatever the value of our token is, right, our score will always get decremented by only 1 in case of face down. And irrespective of whatever the value of our token is, during face up, our score will only get incremented by 1. So we have to come up with an approach that in which we are using this power efficiently. Now, what do I mean by using the power efficiently? It means that whenever I'm doing a face up, I should do a face up in such a way that the value of the token is as less as possible, because I want to invest minimum power. Okay, because if I'll be investing minimum power, then I'll be left with a good amount of power to satisfy or to use it in the future for the another token that might have a larger value, correct? And similarly, whenever we'll be doing a face down, we should use a token that has as max value as possible. Why? Because during face down, we will be adding the value of that particular token to our power. So if the value of that token of I is greater, or let's say it's the greatest value, in that case, what will happen? Our power will become more, and eventually we'll have lot of power, right? Which we can invest in other operations in future, correct? So what we will do is, whenever we'll be doing face up, we'll select a token that has a lesser value. And whenever we'll do face down, we'll select a token that has a greater value. Okay. Now let's see how we can achieve this. So for achieving this, what we'll do, we'll first have to sort the tokens array. Okay. Now one more thing you need to know is that when are we going to do a face up and when are we going to do a face down? So until and unless we have the value of a token such that it's lesser than power, so we will keep on doing face up. And the moment we'll get that our power is not enough, that is, our power is lesser than equal to the current value of the token. In that case, what we'll do? In that case, we'll do face down in such a way that we are using a token which haven't been used and that has the max value, right? So as to gain a good amount of power, correct? And once we have done face down, then again we'll keep on doing face up until and unless our power is greater than equal to tokens of I, correct? So now let's do a quick dry run for this given test case. So as I mentioned that for face up, what we'll use the as less value as possible, right? As less value as possible. And for face down, what we said that as much value as possible, because we want to get more power. And here we want that our less power should be deducted, right? So for face up, we want lesser value, and for face down, we want as max value as possible. So how are we going to achieve the track of the max and the min value? So for that, what are we going to do? We are first going to sort the tokens array, right? We are going to sort the tokens array. And after that, we'll use two pointers, start and end. So say this is start and this is end. So what start will do? Start will keep track of the least value, right? Which we will use for face up. And end will keep track of the max value that we will use during face down. Fine. So let's start the dry run. So initially our power is 200 and score is 0. So we'll see that can we perform a face up. So what is the value present at start? The value present at start is 100, correct? So we will check, is 100 lesser than equal to power 200? That is 200. Because what was the condition for face up? The condition for face up was that tokens of I should be less than equal to power. So is token of I lesser than equal to power? So it's true. So what we'll do? We'll do a face up. So whenever we'll do a face up, what will happen? Our score will get incremented by 1. So our score will become 1. And what will happen? Our power will get decremented by the value of the token. So what is the value of the token? It's nothing but 100. So our power will now become, we'll subtract 100. So it will become 100, correct? Now, since we have used this token, what we will do is we will increment this pointer. So now our start will point over here. Now again, we'll check that can we do a face up? So for face up, what is the condition? That tokens of I should be less than or equal to power. So what is tokens of I? Tokens of I means tokens of start. What is tokens of start? It's 200. So is 200 lesser than equal to current power? Current power is 100. So is 200 lesser than equal to 100? No, it's not lesser than equal to 100. So can we do face up? We can't do face up. So what we'll do? We'll check whether we can do a face down or not. So what is the condition for face down? The condition for face down is that score should be greater than equal to 1, right? So is our score greater than equal to 1? So our score is greater than equal to 1, right? Here you can see that we have a score of 1. So score is greater than equal to 1. So we can do a face down. So whenever we'll do face down, what will happen? Our score will get decremented by 1. So if we decrement it by 1, what we will get? We'll get a 0, correct? And our power will get incremented by tokens of I. Now, we mentioned that for face down, we will consider as max value of tokens of I as possible, correct? So which of the pointer is representing the max value? It's the end pointer, right? So here it would be token of end, correct? And similarly, for face up, what we decided that we want as less value as possible. And which pointer was pointing to the as less value as possible? It was the start pointer, right? So it would be token of S over here, correct? So now what we will do? We decremented our score, so it became 0. And what we have to do? We have to add token of E to our power. So what we are going to add to our power? We are going to add this 400 to our power, right? Because we want to use this power in an efficient manner. So whenever we want to do a face down, since we are adding up the power, so we want as max power as possible to be added, right? So we are going to add this 400. So since we have used this token to perform a face down, so what we will do? We will decrement this end pointer. So it will now point over here. And since we added 100 to 400, what it would become? It would become 500 now. Fine. Now, again, we will check that can we perform a face up, and our start pointer is pointing at 200, end pointer is pointing at 300. So we'll check if we can perform a face up. So for performing a face up, what we are going to check, that is token of start lesser than equal to power. So what is token of start? It's 200. So is 200 lesser than equal to current power? What is current power? It's 500. So is 200 lesser than equal to 500? So this is true. It's lesser than equal to 500. So what will happen? Our score will get incremented by 1. So we will add 1 to our score. So it will become 1. And what will happen after that? After that, we are going to decrement our power by token of start. So what is token of start? Token of start is 200. So we are going to subtract 200. So what is the power left? Now the power left is 300. Correct? And since we have used the token at the start index, what we will do? We will increment it. So now our start is pointing over here. Okay, so now you can see that our start and end both are pointing at the same index. Now again, what we'll check? We'll check that can we perform a face up? So we'll check that what is tokens of S? Token of S is 300. So is 300 lesser than equal to power? What is power? Power is 300. So is 300 lesser than equal to power? So it's true. So what we'll do? We'll perform a face up. So what we'll do? We'll increment our score by 1. So we'll increment our score by 1. So we'll get a score of 2. And after that, we'll decrement our power by tokens of start. So what is token of start? It's 300. So we'll decrement it from our current power. So our power will become 0. And since we have used this particular token, what we'll do? We'll increment our start pointer. So our start will point at the index 3, right? As the element present at index 3. Now that you have seen that our start pointer has crossed over the end pointer, right? So what does it mean? It simply means that we have completely exhausted the array. Why? Because our end pointer was moving like this and our start pointer was moving like this, right? This was the start, this was the end. Since our start pointer has crossed over the end pointer, it means that we have completely exhausted the array. So it means that we don't have enough tokens left, right? We don't have enough token left. So what we'll do, we'll simply return the score. So what is the score? The score is 2. And this is the max possible score that we can achieve. So our answer would be 2. So I hope now it is clear to you that first of all, we are going to sort the tokens array. And why are we going to do that? Because we want to use this power in an efficient manner, right? Because irrespective of whatever the value of token is, whenever we'll do a face up, our score will get incremented by 1, and in case of face down, our score will get decremented by 1. So what is the value which is getting affected by the value of the current token? It's nothing but power, right? It is getting affected by the value of current token. So we want to use power in an efficient manner. So whenever we'll do a face up, we want to ensure that the value of token of S is as less as possible. And whenever we are doing face down, the value of token is as max as possible, right? Because in that case, we will be able to maximize the power. Okay. So for that particular reason, to keep track of the as less value as possible and as max value as possible, what we have done is we have sorted the array. And after sorting the array, the start pointer is helping us to keep track of the as less value, which we'll use for face up. And the end pointer is keeping track of the as max value, which we'll use in case of face down, correct? And until and unless when we'll do a face up and face down, we'll do face up until and unless the tokens of S is lesser than equal to power, correct? And whenever we'll see that we don't have enough power, what we'll do? We'll simply do a face down by checking the condition that our score is greater than equal to 1, and we'll do a face down, okay? And if we don't have enough token or power or score, in that case, what we'll do? We'll simply return the score, which will represent us our max possible score available, okay? Now let's quickly code this problem. So first of all, we'll take the 2 pointers, start, which will be initially 0, and end, which would be tokens dot size -1, okay? And after that, what we have to do? We have to sort the tokens array, right? Tokens dot begin, tokens dot end. Fine. Let us also take an integer that will represent our score. Initially, our score is 0, okay? Now, what we'll do? Until our start is lesser than equal to end, we will first check for face up, right? Face up. So when we can do face up, we can do face up when tokens of start is lesser than equal to par, correct? So if our tokens of start is lesser than equal to power, we'll do a face up. And whenever we'll do a face up, what will happen? Our score gets incremented by 1 and the value of power gets decremented by the value of the current token. So our score will get incremented by 1 and power will be power minus tokens of start, correct? Now, if we don't have enough power, what we will do? We'll do a face down, correct? We will do face down. So before doing a face down, what we'll check that we should have an element, right? Correct. If we don't have any element left, then is there any point of doing a face down? No. The reason being, if we do a face down, our score will get decremented by 1, right? And if we don't have any element left, so there is no point of decrementing our score, correct? So first of all, we'll check that whether we have an element left or not. Okay. And additionally, what was the additional check? The additional check was that our score should be at least 1. That is, our score should be greater than equal to 1. So if this condition hold, what we'll do? We will decrement our score, and we'll increment the power by the value of the current token. So we will say that score minus minus and power plus equals to tokens of end. Why end? Because the end pointer is keeping track of the max value, right? And whenever we were doing face down, what we wanted? We wanted the max value because we wanted to increment our power by a greater amount, correct? Else, what we'll do? Now, what will come to the else condition? That is, we cannot do a face up and we can't do a face down. Then it means what we'll do? We'll simply return score, because it shows that we don't have enough power. Then only we are not able to do face up. And if we won't be able to do face down, then what does it mean? It means that we don't have enough score. So we'll simply return score in that case, because we don't have any power, so we can't do face up. We don't have any score, we can't do face down. So we'll simply return the score. And once we have completed the iteration, what we'll do? We'll return our score. Fine. Here it should be start and end. Sorry. It should be start less than end. My bad. And additionally, since we have used this particular token, so what we have to do? We have to increment our start pointer, right? And here, since we have used the value present at the end pointer, what we have to do? We have to decrement our end pointer, correct? Let's run it. So it's giving us the correct answer. Let's submit it. So it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the tokens array, that is, let's say this is the tokens array, and if we consider its size to be n, then the time complexity is order of n log n. Why? Because here you can see that we are using the sort function, correct? And it takes a time complexity of n log n. And you can see over here that we are iterating over the complete tokens array, right? And this is costing us a time complexity of order of n. So order of n log n plus order of n is nothing but it's order of n log n, correct? So that's the reason why our time complexity is order of n log n. Additionally, you can see that the space complexity is order of log n. Why? Because in case of C++, the sort function internally uses a space complexity of order of log n. And if you are using Python or Java, in that case, the space complexity may differ. So that's all about today's daily LeetCode challenge. Thank you.